Good day, viewers all over the world. You are welcome to Toydel online class. So, we want to continue from where we stopped in the last class. So, I'm going to start from conjugate complex number. So, conjugate of complex number. So, when I introduce complex number, I said if you have x is equal to a plus ib. So, a is the real part and b is the imaginary part in a given complex number. For instance, we can have x to be equal to 2 plus 3i. So this I is talking about the imaginary part, while 2 is the real part. And we are given this condition that I is equal to square root of minus 1, so that I squared will be equal to minus 1. So we must be conscious of this fact. So in the last class, we've talked about addition and subtraction of complex number. So I've also introduced multiplication of complex number. So today we are going to start from the conjugate of complex number. That is, why do we need conjugate? Of course, when you recall that when we discuss sort, if if we have 2 plus 3i, this is a typical complex number. The conjugate of this complex number will be 2 minus 3i. That is, conjugate simply means you should reverse the sign. If the sign is plus, its conjugate will be negative, and if it is negative, its conjugate will be positive. Every other thing remains. It's only the sign that will change. So if you have a complex number, and this is conjugate of a complex number, so if you multiply a complex number with its conjugate, you are going to get a real number. That is this what I'm saying. For instance, if you expand this, what do you get? This will be 2 times 2, 4. 2 times minus 3i minus 6i. 3i times 2 plus 6i. Then plus times minus, that's minus 3 times 3, 9i squared. So minus 6 we take care of plus 6. So we have 4 minus, of course, I squared is equal to minus 1. So if you have 9 multiplied by minus 1, that's 9 minus times that's minus 9. Minus times minus plus. So you have 9, you have 4 plus 9. At the end of the day, the answer is 13. So this simply means that when you use a complex number to multiply its conjugate, you are going to get a real number. So please, let's take notes. We should take note of that. And in general, if you have say a plus ib to multiply its conjugate, the conjugate of this will be a minus ib. Then you are going to have a squared minus iab plus iab, then minus b squared I squared. This will take care of this. You are going to have a squared minus b squared into bracket minus 1. Minus times minus is plus. So you have a squared plus b squared. So when you use a complex number to multiply its conjugate, you are going to get a real number. So why do we need the knowledge of complex number? Why do we need the knowledge of conjugate complex number? This knowledge is required when we want to find the division of complex number. That is, let me just give one example. Let's say example under conjugate complex number. Simplify 3 minus 5i multiplied by 3 plus 5i. That is, if you have what you have on the board, if you have to simplify this, what do you get? You have 3 minus 5i multiplied by 3 plus 5i. So if we expand this now, 3 times 3 will be 9, 3 times 5 will be 15i, minus 3 times 5 will be minus 15i, the minus times plus minus 5 times 5 is 25i squared. So here we are going to have 9. 15i will take care of minus 15i. We have minus 25 into brackets. We note that I squared is equal to minus 1. So that will be minus 1. Then I'm going to have 9 minus times minus plus 25, and that gives 34. So please take note that if we have a complex number and multiply it by the conjugate of that complex number, we are going to get a real number. So we should take note of that. And the reason why we have conjugate complex number is whenever we want to do multiplication of complex number, the knowledge of conjugates will be required. So I would introduce division of complex number. We have talked about subtraction, addition, subtraction, and multiplication. So now let's talk briefly on division of complex numbers. Okay. So under this division now, if you are given a complex number, how do you divide two or more complex number? So to divide one complex number by another, we multiply both the numerator and denominator by the conjugate of the denominator. For instance, if you are given a plus ib divided by c plus id, so if you are given this now, what are you expected to do? Just say you are going to multiply both the numerator and the denominator by the conjugate of this denominator. Then the denominator is c plus id. The conjugate will be c minus id all over c minus id. So if you are given a complex number in form of division, you rationalize. That's the term. So what do? You multiply both the numerator and the denominator by the conjugate of this denominator, which is given as what we have on the board. Then you now open up. We are going to have a plus ib multiplied by c minus id all over c plus id multiplied by c minus id. So in this case now, if we open up the numerator, we are going to have ac minus iad plus ibc minus bd I squared all over. If you look at the denominator, you are going to have c squared minus icd plus icd minus d squared I squared. Note that I squared is equal to minus 1. I squared is equal to minus 1. So this will take care of this. So this will take care of this. So in this case now, what do we do? Look at the effect of this. I squared is equal to minus 1. So if I change this, I'm going to have AC minus, I can say plus I into BC minus AD. I try to rearrange this. Then I will have minus BD here. I squared is equal to minus 1. Let's note that. All over at the denominator, we have C squared minus D squared into bracket I squared. Then here, I'm going to have minus times minus is plus. So I will have BD here. So finally, we are going to have AC plus BD plus I or plus into bracket BC minus ADI, everything all over C squared minus times minus is plus D squared. So look at the effect now. If you use a complex number to multiply its conjugate, at the denominator, you don't need to stress yourself. Just square the first value that we are given. C squared will give us C squared. Then also square the second value. That will be D I squared D squared. D squared is there, I squared minus 1. So that's where we have this minus. So it changes to plus. So this is what we are going to have. So that's just the general form. So let's give specific example now under division of complex number. So say example 2. I will say simplify the first one. 3 plus 5i all over 5 minus 3i. Then let's take second example. Say 2 plus 3i multiplied by 1 minus 2i all over 3 plus 4i. Okay. So if this is what we are given, so how do we go about this? A is 3 plus 5i all over 5 minus 3i. For us to be able to simplify this now, we are going to multiply both the numerator and the denominator by the conjugate of this denominator, and that will be 5 plus 3i all over 5 plus 3i. So when we open up our denominator, we are going to have 3 times 5, that's 15. 3 times 3, that's plus 9i. Then 5 times 5, that's plus 25i. Then plus times plus, that's plus 5 times 3 is 15. That will be 15I squared all over. And the denominator, you don't need to stress yourself. Just square the first one here. I'm going to have 5 squared because when you open up, the what we have in between will cancel out. Then minus 3I squared. So at the end of the day, I squared is equal to minus 1. So let's take note of that. I'm going to have 15 plus 34I, then plus 15 into bracket minus 1. I squared is equal to minus 1. All over 25 minus, no, this will be 3I. Then we are going to have 9I squared. When we take the square root of this, it's going to give us 9I squared. I squared is equal to minus 1. We are going to have minus 9 into bracket minus 1. At the end of the day, we have plus times minus is minus. We have 15. This will now be 15. 15 minus 15. We have 15 minus 15 plus 34I all over. This is 25 plus 9. So 15 minus 15 we cancel out. At the end of the day, we are going to have 34I all over 34. This will take care of this. At the end of the day, the final answer will be I. So when you simplify that, this is what we are going to get. So whenever we have division of a complex number, this is what we are expected to do. Just multiply both the numerator and the denominator by the conjugate of the denominator. Then you simplify. So we take the second example. We're going to take the second example where we have 2 plus 3I multiplied by 1 minus 2I all over 3 plus 4I. So in this case now, we first expand the numerator before we use the conjugate. That is, if I expand the numerator, I'm going to get 2 minus 4I plus 3I minus 6I squared all over 3 plus 4I. Then I squared is equal to minus 1. Let's note that. So here now, I'm going to have minus 6 into bracket minus 1. Minus times minus is plus. So I'm going to have 2 plus 6. That will be 8. Then minus 4 plus 3 minus I all over 3 plus 4I. At this point now, we rationalize. We have 3 minus 4I all over 3 minus 4I. Then if I expand this, I will have 8 times 4. 8 times 3, that's 24, minus 32I. Then I will have minus 3I plus 4I squared all over. I will square the first one, that will be 9. Minus, I will take the square root of the second one, that will be 16I squared. So from there now, I squared is minus 1. So I will have 4 multiplied by minus 1, that's minus 4. 24 minus 4, that gives 20. Then minus 32 minus 3, that's minus 35I all over 9. 3 squared is 9. I'm going to have 9. Then I squared, this will be 16 to bracket minus 1. Minus times plus. Minus times minus is plus, so I will have plus 16. So finally, I'm going to have 20 all over 25 minus 35I all over 25. So I can reduce this to 4 over 5 minus 7 all over 5I. And that's what we are going to get. So under division of complex number, we should know that. Okay. So under complex number, we can have complex number in various form. We can have complex number in various form. But the normal form that we have is called the standard form. That's what we have been using. That is, if you have Z to be equal to X plus IY, this is called the standard form. The standard form of complex number. And this is what we are used to. So from this standard form now, we can rewrite this in another form. We can rewrite this in polar form. We can write it in exponential form. Then we can also rewrite this complex number in logarithmic form. So what do we do? So if we want to express this now, we want to move from standard form to polar form. Then we use what we call the argand diagram. The argand diagram. We use what is called the argand diagram. That is, under the argand diagram, we are going to have this as the imaginary Z. That is the imaginary part. The vertical will represent the imaginary part, while the horizontal will represent the real part of Z. Then we have this Z will be equal to X plus IY. That's what we are going to get. So if we trace this here, I'm going to have Y here. Then here, I will get X. Then the angle of inclination here with the vertical, let's represent it as theta, so that this place will be r, which is called the modulus. We're going to call this the modulus. So if you now consider this triangle now, this triangle that we have, of course, is a right angle triangle. So if I apply Pythagoras theorem, I can actually find the value of this r, or this r is also denoted as modulus of z because it's called modulus. So if I say z squared representing this r, the modulus, is same thing as what? S squared plus y squared, Pythagoras theorem. Then z squared, this z will now be square root of s squared plus y squared. From this diagram, that's what we are going to have. So from this diagram, that is what we are going to have. So from there now, we can say r is equal to modulus of z, which is equal to square root of s squared plus y squared. So this one is called the modulus. It's called the modulus of, when we have the standard form, is this represents the modulus. Then not only that, look at this angle theta. Of course, if you want to find this angle theta, we are going to use SOHCAHTOA. So to get this angle theta in form of x and y, in form of what we define here, we can say tan theta. We can say tan theta is equal to y all over x, because under SOHCAHTOA, TOA simply means, tan simply means opposite all over adjacent. Then if I want to find tan, that will be arctan of x, y all over x. That is what we are going to get for us to be able to find that. Then this angle theta represents the, that will represent the arc z, that is the argument of that, and that gives what? Arctan y all over x. So we should note that if you are given the standard form of a complex number, where r is called the modulus of the complex number, which is defined as what you have on the board, and where theta is called the argument of the complex number, and is given as theta. So theta is, the abbreviation for theta is arc z, which is equal to arctan y all over x. So if you're able to get these two, then we can actually move from standard form to polar form. So let me just give one example on this. On this, then we generate the polar form of complex number. Okay, let's say example 3, where we have, the question says find the modulus. Find the modulus and the argument of the complex number 4 plus 3i. So this is what we are given. Let's say z, the complex number, let's denote it as z, is equal to what? 4 plus 3i. So the question says we should find the modulus and the argument, that is modulus with the modulus of z. So we know we represent the modulus as r, which is equal to the modulus of z. By formula, it's given as what? S squared plus y squared. So s is the real part, y is the imaginary part. So if we do that here, we are going to have square root of 4 squared plus 3 squared, and that will give us square root of 16 plus 9. So r, which is the modulus of z, is given as what? Square root of 25, and is equal to 5. So in this case now, in this complex number now, the modulus is given as 5. Then how do we get the argument? Of course, we know that the argument is theta. It's same thing as arc z, which is equal to arctan of y. Y is 3 all over 4, which is x. Then this is equal to arctan of 3 divided by 4 is 0.75. So you can use the standard, you can use your four-figure table to find this, or you press shift, then tan is gives arctan of this. So if you do that correctly, it is approximately 37 degrees when you use your calculator to check. So this is how to find the arguments, the modulus and argument of the standard form of a complex number. Then why do we need the argument, the modulus and the argument? This knowledge is needed for us to be able to convert from standard form to polar form of a complex number. And I'm going to introduce that briefly. That is the polar form. This is the standard form. So let me introduce the polar form. The polar form of a complex number. I've just introduced the polar form of a complex number. So What do we do if you want to find the polar form of a complex number? So for instance, of course, we have introduced this to be the real parts and this to be the imaginary parts. So we call this x, then we call the imaginary part y. So if this is what we have, let's say this is theta argument, then let's define z as what? A plus ib. It could be anything. I is just telling us that this b is the imaginary part, while the one without r is telling us that this is the real part. So here will be b because it's the imaginary part. The vertical is imaginary, the horizontal is the real part. This is a. Then here is our r, which is the modulus. So r, we know that r is equal to square root of a squared plus b squared. That is r. Then this angle theta, we know that angle theta is equal to arc tan. No, let's just say tan theta. Tan theta is equal to opposite all over adjacent. That will be b all over a. Tan theta will be b all over a. Then, if you want to change this z now, this standard form to polar form, there's need for us to find a and b. So when we look at this diagram very well, if I say sine a, sine theta will be what? Opposite all over hypotenuse. That will be b all over r, right? Then if I say cos theta will be what? Adjacent all over hypotenuse. That is a all over r, a all over r. So I can make b the sum of the formula when I cross multiply. B will be equal to what? R sine theta. That is b. Then a will be equal to what? R cos theta. That is what we are going to get. So if this is what we are going to get from this diagram now, I want to rewrite this complex number from this standard form to polar form. Then let me substitute for a and b using r sine theta and r cos theta. That is, z is given as what? A plus ib. That is z. So if I substitute, what is my a? A is r cos theta plus I, the b is r sine theta, r sine theta. Then z can be equal to, r is common, I can bring out r. Then what do I have left? Cos theta plus I sine theta. So this is the polar form of a complex number. So this is the polar form. So we can actually convert from standard form. This is the standard form. This is the standard form. This is the standard form of a complex number. Why this is the polar form of a complex number. So this is what you are going to have. If you want to convert from standard to polar form, this is the formula. Then where r, of course, we know that where r is called the square root of a squared plus b squared. So if you are given a standard form, you can be asked to convert it to a polar form. This is how to move. This is the polar form. Then not only that, we can even have exponential form. We can also rewrite this in exponential form. That is, we can also have exponential form. Exponential form. Exponential form. Exponential form of a complex number. We can have exponential form of a complex number. So all that is required here is just to do some conversion. Then we are going to get the exponential form. Let me let me silent about the exponential form now. Let's give example on the polar form. So let me give example on polar form, then we go to exponential form some other time. Let's give example of polar form. Example 3, or let's say example 4. The question says express z is equal to 3 plus 5i in polar form. So let me express this in polar form. So by the time I introduce exponential form, I'm also express this in exponential form. Then we are going to see the difference. So in this case now, how do I convert this to polar form? Of course, I will need r, which is the modulus. From here now, z is equal to 3 plus 5i. This is the real part. I can call this maybe a. I can call this a. Then I call this b. Okay. So my r will be equal to square root of a squared plus b squared. That is r, which is the modulus. Then I will have square root of, this is 3 squared plus 5 squared. So I'm going to have square root of 9 plus 25. That will be square root of 34. That will be the modulus. So then square root of 34 is approximately 5.83. That's what I'm going to get. Then I also need to find theta. Theta, no, I would say tan theta is equal to, tan theta will be b all over a. So in this case, this is 5 all over 3, and that's same thing as 1.4. Then my theta will now be arctan of 1.4. Then theta will be approximately 54.5 degrees. So that will be the value of theta. Then what am I going to do now? I'll just say z is equal to r into bracket cos theta plus I sin theta in polar form. This is the polar form of a complex number. Then what do I do here? I'll just substitute. What is r? R is given as what? 5.83 into bracket cos 54.5 plus I sin 54.5 degrees. That's what I'm going to get. Then here I will have 5.83 into bracket. I will have 5.83. So I'm going to get 5.83 into bracket. What is cos 54? 54.5. So 54 under 5. You can check from the forgot table. That will give 0.5807 plus I sin 54.5 give 0.8141. So from there, we are going to have, I can open up, I can use this to multiply this. I'm going to get 3.386 plus 4.746i. So that's what I'm going to get. That's what I'm going to get in polar form. This will be the value of z. This will be the value of z in polar form. This is the value of z in polar form. From, we are given z to be equal to, in standard form, we are given z to be equal to 3 plus 5i. So if this is standard form of z, then if you convert this from standard form to polar form, this is what we are going to get as the value of z in polar form. So as I've said earlier on, we can write complex number in various form. We can write it in standard form, we can write it in polar form, we can write it in exponential form, and we can also write it in logarithmic form. So far, we have been able to look at the standard form of complex number. Then I've introduced the polar form briefly. So by the grace of God, we are going to continue from there. So in our next class, I'm going to introduce the exponential form of a complex number. Then I'll also introduce the logarithmic form of a complex number. So I would love to stop here because of our time. So if you have any question on that complex number, you can just type it at the comment section. I promise to attend to it. Thank you, and God bless you.